Have you ever been in the shower or driving or trying to fall asleep? And then, without any warning, it comes back. The argument that happened 6 months ago. The moment you said something you shouldn't have. The awkward silence after a joke that didn't land. The mistake that, from a practical standpoint, was resolved a long time ago. Not a vague memory, a memory with texture, with temperature, with the exact feeling in your chest that existed in that moment. And the question that arises, almost inevitably, is this: why is this still here? The problem has already been solved. The argument ended. The mistake was corrected. The moment passed, and the calendar can prove that with precision. But something in the nervous system seems not to have received that information. Or, if it did receive it, it doesn't fully believe it. To understand why this happens, we need to look at one of the most important and most counterintuitive discoveries in the neuroscience of memory over the past few decades. Not all memories are stored in the same way. In the 1990s, neuroscientist Larry Cahill at the University of California, Irvine conducted a series of experiments that revealed something fundamental. When situations with significant emotional content are experienced, the amygdala, an almond-shaped structure located in both hemispheres of the brain, releases a signal that acts quite literally like a marker, a biological stamp placed on the memory being formed that communicates to the hippocampus and other structures. This is important. Store it with priority, with detail, with as much context as possible. This process became known as emotional tagging. And what it produces is a memory that is qualitatively different from memories of neutral events. Think about the difference between trying to remember what you ate for lunch on some random day in October last year and remembering exactly where you were, what you were feeling, and what you were wearing when you received very good news or very bad news. The first event may have happened more recently, but the memory of the second is more vivid, more detailed, more accessible, and more persistent. Not because the second event was necessarily more important in the rational sense of the word, but because the second event activated the amygdala in a way the first one did not. And an activated amygdala changes the chemistry of the consolidation process. Researcher James McGaugh, also at the University of California, Irvine, spent decades mapping this process. What he documented is that hormones released during states of emotional arousal, especially adrenaline and norepinephrine, act directly on the hippocampus and the amygdala during the hours that follow a significant event, not during the event itself. After it, during the hours when the brain is quietly consolidating what happened. That has an implication few people ever consider. The strength of an emotional memory is not determined solely by the intensity of the event at the moment it occurred. It is co-determined by the amount of hormonal processing that happens in the hours afterward, while you appear to be doing something else, while you're having dinner, or trying to watch a show, or talking to someone, or sleeping. The system is working, encoding, prioritizing, making that memory increasingly stable and increasingly available for future access. But stable and available doesn't just mean easy to remember when you want to. It also means easy to activate through cues that the system associated with that memory, even when those cues are completely accidental. A similar tone of voice, a specific word, a smell, a body posture, anything that happened to be present in the environment during the original event. This explains why many of these memories don't arrive when you're actively thinking about them. They arrive when you're not expecting them, because what activates them is not the conscious decision to remember. It's an environmental signal, sometimes so subtle you don't even notice it, that the system connected to that memory during consolidation. The amygdala operates according to this logic automatically and non-verbally. It doesn't check your calendar. It doesn't verify whether the problem has already been solved. It doesn't ask whether 6 months have passed. It detects a pattern that resembles what was present when the emotional marker was originally placed, and it reactivates the response associated with it, not as a flaw in the system, as exactly what the system was built to do. Store emotionally significant situations with high fidelity and keep them available, especially when signals appear that resemble those situations. The problem is not that the system is primitive or defective. The problem is that it is extraordinarily efficient, and that efficiency was calibrated for a very different environment from the one we live in today. In the environment where this system evolved, A vivid emotional memory associated with a specific threat was literally a matter of survival, accurately remembering what looked, sounded, or smelled like the situation that almost caused harm meant a greater chance of surviving the next encounter. For the nervous system, there is not much evolutionary difference between remembering accurately in order to survive and continuing to relive something that has already passed. From a design perspective, those are the same operation. And this is where the first piece falls into place. The brain is not stuck in the past because it lacks rationality. It is executing, with precision, a memory prioritization system that was built to keep emotionally significant information active indefinitely if necessary. The issue is that indefinitely wasn't a problem in the environment where this system evolved, because in most situations involving real threats, resolution was physical, immediate, and unmistakable. The threat either passed or it didn't. In the modern environment, threats are often social, ambiguous, and lacking a clear physical resolution. An argument ends, but the implications remain. A mistake is corrected, but other people's perception may have changed. A moment of embarrassment passes, but the question of "what does that say about me?" rarely has a simple answer. And the emotional tagging system, built to capture threats with clear edges, continues processing situations whose edges are blurry. It keeps checking, keeps the file open, because no unmistakable signal that says, "this is resolved," has yet been registered. There is a window of time in the hours following an emotionally intense event during which the memory is still being formed, not permanently stored, formed. During this process, what neuroscientists call consolidation, the memory is, in biological terms, still malleable, like clay that has not yet fully hardened. And it is being actively shaped by the hormonal activity that the event itself triggered. The hippocampus is the central structure in this process, and its role goes far beyond simply storing what happened. It is responsible for dating a memory, for attaching a label that says, "this happened at a specific time, in a specific context, which now belongs to the past." When the hippocampus is functioning at full capacity, this temporal contextualization occurs with relative efficiency. The memory is stored with what could be called an emotional timestamp. This happened, it belongs to the past, it can be accessed when necessary, but it does not need to remain on alert. Neuroscientist Bruce McEwen from Rockefeller University spent decades documenting what happens to the hippocampus under prolonged exposure to elevated cortisol, the primary hormone released during sustained states of stress. What he found was direct and, in some ways, unsettling. Chronic stress measurably compromises the functional capacity of the hippocampus. It reduces neurogenesis in the region. It alters the density of synaptic connections. And, especially relevant to what we are exploring, it affects how accurately the hippocampus can place memories in time. When that ability is compromised, the memory is stored, but without a clear label indicating when it belonged, or with an imprecise label, with more diffuse temporal boundaries. And a memory without a clear temporal label does not arrive with the feeling of belonging to the past. It can arrive, and often does, with something that feels, strangely, like the present. This is where sleep enters the conversation in a way that is rarely considered. The research of Matthew Walker at UC Berkeley and Robert Stickgold at Harvard has built, over decades, a detailed map of sleep's role in memory consolidation. What they documented is that, during deep sleep, and especially during REM sleep, the hippocampus and the cortex communicate intensely and in a highly coordinated manner. Memories formed during the day are gradually transferred from the hippocampus to the cortex, where they become more stable, more permanent, and more integrated into existing knowledge. Researcher Rosalind Cartwright, who devoted decades to studying dream content and its emotional function, proposed that REM sleep also serves as a space for effective processing. An opportunity for the nervous system to revisit emotionally charged memories under conditions of lower arousal, gradually separating, across repeated sleep cycles, the factual information from the emotional charge attached to it. Over time, with adequate sleep, a difficult memory can be accessed without activating the entire original physiological response. The fact remains, the emotional intensity decreases. The problem is that this process requires exactly what is hardest to provide after an emotionally disruptive event. Quality sleep, complete sleep, sleep that reaches the stages necessary for this work to happen. Because the very memories that need to be processed during sleep are often the ones that interfere with it the most. The mind that keeps revisiting the scene at 2 in the morning. The difficulty reaching deep sleep precisely on the nights following something that shook the system. The feeling of waking up still carrying the weight of what happened, as if rest had been too superficial to make any difference. It is a cycle that sustains itself. The unprocessed memory interferes with sleep. Compromised sleep reduces the ability to process the memory emotionally, and the memory, without that processing, remains available with the same intensity with which it was originally formed. In 2000, neuroscientist Karim Nader published a study that profoundly shook the field of memory neuroscience. Until then, the dominant theory held that once a memory was consolidated, it was essentially stable, a recorded and sealed file. Karim Nader demonstrated something radically different. Every time a memory is activated, every time it is accessed, revisited, or simply recalled, it temporarily enters a new state of malleability. It must be reconsolidated, stored again. And during this reconsolidation process, which lasts for several hours after retrieval, it can be modified by new information present in the current context, by new emotions present at the moment of recall, by new associations the environment provides. This has a consequence that completely changes the way we understand what happens when you mentally revisit that moment. The argument, the mistake, the moment of embarrassment. Every time you return to that scene, you are not simply remembering, you are reconsolidating. And if the emotional state present during that retrieval still carries tension, self-criticism, or shame, those emotions become incorporated into the memory during reconsolidation, making it, in some cases, even more emotionally charged than it was originally. Each anxious review can, paradoxically, strengthen the very memory you are trying to leave behind. There is another phenomenon that deepens this pattern in a way many people immediately recognize but rarely know how to name. Psychologist Gordon Bauer from Stanford University documented in the 1980s what became known as state-dependent memory. The central idea is this: memories are more easily accessed when the emotional state present during retrieval resembles the emotional state present during the original encoding. In practical terms, memories encoded in a state of anxiety are more easily activated when you are anxious. Memories encoded in a state of shame return more intensely when something today makes you feel ashamed, even if it is a completely different situation. This means that on days when the nervous system is already overloaded for other reasons, a difficult week, a hard conversation, an accumulation of small frustrations, those memories that seem to be behind you may return with renewed intensity, not because they became stronger, but because the current emotional state is opening the door to them, the same state in which they were originally encoded. If this describes something you recognize in your own system, that feeling that certain memories always return at the wrong moments, with an intensity that seems disproportionate to the amount of time that has passed, this channel exists to put a name to exactly that. Every video here connects a new piece to the map of how the mind actually works. Subscribe so the next one is already waiting for you. But there is still something that none of these mechanisms, on their own, fully explains. Why do some memories keep returning even when sleep has been reasonably good? Even when there is no obvious environmental trigger, even when the person is not in a particularly difficult emotional state? Why is it that, in moments of silence, in the shower, in traffic, in the minutes before sleep, the system seems to actively choose that file, among all the available ones, to revisit? The answer lies in a brain network that the mind activates systematically every time you are not doing anything in particular. And what that network does with free time is one of the most surprising discoveries in the neuroscience of the last 2 decades. In the early 2000s, neuroscientist Marcus Rachel at Washington University was analyzing functional neuroimaging data when he noticed something that did not fit the prevailing logic. There was a set of brain regions that, instead of decreasing their activity during periods of rest, increased it. Not slightly, significantly, as if the brain, freed from any external task, did not rest at all, but simply changed occupations. Rachel called this collection of regions the default mode network, and what decades of subsequent research have revealed is that this network is not a standby system. It is a system with its own function. a specific function that the brain performs whenever conscious attention is released from the immediate task at hand. That function is closely connected to something psychologist Endel Tulving at the University of Toronto described as mental time travel. Tulving identified that human beings possess a rare ability, possibly unique among species, to mentally transport themselves to other moments in time. Not merely to remember what happened, but, in a sense, to be inside a memory from the past, with sensory texture and emotional presence, or to project themselves into the future with the same kind of lived anticipation. The brain regions that support this mental time travel, the hippocampus, the medial prefrontal cortex, and the posterior cingulate cortex, are precisely the regions that make up the default mode network. This is not a coincidence. The system the brain activates in silence is the same system that travels through time, and when that system is given space to operate, in the shower, in traffic, in the minutes before sleep, it does not wander randomly through the past or the future. It consistently gravitates toward the points the system considers emotionally relevant and not yet resolved. Think about how this appears in everyday life. An entire afternoon of focused work may pass without that difficult memory appearing even once. But the moment concentration is released, in the gap between meetings, on the drive home, during the first real pause of the day, there it is, with the same clarity as before. Silence does not summon these memories by accident. It simply removes what was preventing the system from reaching them. And this is where a distinction emerges that completely changes how we understand what is happening during that return. Psychologist Susan Nolan-Hoeksema, who spent her career between the University of Michigan and Yale, devoted decades to studying the patterns of thought that accompany difficult emotional states. What she identified and documented with increasing precision over time is that there is a fundamental difference between two processes that, from the outside, can appear identical: rumination and processing. Genuine processing of an emotional memory requires that the memory be accessed, contextualized with new information, integrated into a broader narrative, and eventually stored with a meaning that can be carried forward. It is movement. It goes from some point A to some point B, even if slowly, even if with difficulty. Rumination is the system returning to the same file, opening it, closing it, opening it again, without new context, without integration, without any movement toward point B. It is less a process of resolution than a repeated verification that the problem still exists. Nolan-Hoeksema documented that rumination does not merely maintain negative emotional states, it prolongs them. People with a more ruminative processing style recover more slowly from difficult events, not because the event is objectively more severe, but because the pattern of repetitive access without resolution keeps the emotional system in a continuous state of processing, like a wound that is reopened before each attempt at healing. And the crucial detail is this: the nervous system, by itself, does not automatically distinguish between rumination and processing. It only registers that the file has been opened, and based on what we explored in the previous section about reconsolidation, every opening, regardless of intention, restarts the consolidation clock for that memory. The result is that many people who are actively trying to get over something by thinking about it, mentally reviewing it, trying to find the right perspective, may inadvertently be keeping the memory fresher, more active, and more emotionally present than it would be if it were accessed less frequently. Not because of a lack of effort, because of too much returning. There is a point in this story that researcher and clinician Bessel van der Kolk articulates in a way that is difficult to hear without recognizing something in yourself. The nervous system does not organize experiences according to chronological time. It organizes them according to the degree of complete emotional processing. An event that happened 10 years ago but never found the conditions necessary to be fully processed can arrive in the present with the same emotional intensity as something that happened last week. And an event that happened yesterday but found the space, support, and resources needed for integration can begin to feel like the past much sooner than the calendar would suggest. The time that passes on the clock is not the time the nervous system records. For the nervous system, a memory is not in the past because it happened a long time ago. It is in the past when it has been fully processed. And complete processing is not automatic. It is not guaranteed by the simple act of surviving the event. It is not produced by an act of will or by deciding to move on. This is why situations that, from the outside, would appear to have been resolved long ago, according to the logic of elapsed time, changing circumstances, or practical resolution, continue to arrive with an emotional presence that challenges that external assessment. Not because the person is choosing to stay stuck, but because the processing within the internal system has simply not yet reached the archive stage. If any part of this describes something you recognize, that feeling that a situation already resolved still returns carrying more weight than it should, this channel exists to name exactly that. Every video here adds another piece to the map of how the nervous system actually works. Subscribe so the next one is already waiting for you. But there is one final layer to this story, and it may be the most revealing of all. Because so far we have talked about how these memories arrive, how they are consolidated, and how the system keeps them active. What has not yet appeared is why, when reliving a difficult moment, the body reacts as if that moment is happening now, not as if it were a memory, as if it were a present experience. And the answer lies in a place most people would never think to look. Not in the hippocampus, not in the amygdala, in the tissue of the body itself. Neurologist Antonio Damasio spent decades investigating something that neuroscience for a long time almost completely ignored: the relationship between the body and emotional memory. In his work on what he called somatic markers, Damasio proposed something that goes beyond psychology and neuroimaging. Emotions, he argued, are not merely mental phenomena. They are, first and foremost, bodily phenomena. Every significant emotional state the organism has experienced leaves a trace, not only in the hippocampus or the amygdala, but in the body itself, in the tension of specific muscle groups, in posture, in breathing patterns, in visceral activation, in heart rate. These bodily traces are what Damasio called somatic markers, and they function as a kind of parallel memory, stored not in the brain alone, but within the tissue of the body itself, that becomes activated alongside the corresponding emotional memory. This has a direct implication for the pattern this entire video has been exploring. When an emotionally charged memory is activated, it is not merely a collection of mental images that returns. It is an entire bodily constellation. The tension that existed at that moment, the tightness in the chest, the acceleration of the heartbeat, the contraction in the shoulders, the way breathing became shorter and more restricted. And this bodily response is not a consequence of the emotional memory. It is a constitutive part of it. The body and memory are, in the most literal sense, inseparable. This means that the nervous system does not automatically distinguish between "I am reliving this moment" and "I am living this moment," because the bodily response, which is part of the threat evaluation system, is identical in both cases. The same constriction, the same tension, the same physiological state. And the threat evaluation system, operating on the basis of these bodily signals, does not read the calendar. It reads the body. And the body is saying, "This is happening now." That is why, when intensely revisiting a difficult moment from the past, the body does not seem to be remembering, it seems to be responding. Because from the perspective of the system that regulates alertness, that is exactly what is happening. Researcher Peter Levine, who spent decades developing the field of somatic psychotherapy, observed a pattern in wild animals that became central to understanding this process. Animals that survive highly threatening situations, a gazelle escaping a predator, for example, often go through a period of involuntary shaking and physical agitation immediately after the escape. This is not trauma. It is the opposite. It is the nervous system completing the mobilization cycle that was activated during the threat, dissipating, through physical movement, the energetic charge that was generated to sustain the escape response, and then returning, after that cycle is completed, to a resting baseline. In humans, that cycle rarely completes itself in the same way, because the social and cultural environment places a high value on emotional control and interrupts the process before it reaches its conclusion. The child who becomes frightened feels the impulse to cry or shake and hears, "Stop, you're fine," is learning from an early age to interrupt the cycle before it is complete. The adult who endures a week of intense pressure and holds it together throughout the entire experience carries a mobilization that never found an outlet. And a cycle that is never completed does not disappear. It remains stored in the body as a charge that the nervous system continues to carry, contributing to the feeling of always being slightly tense, rarely fully at rest, and vulnerable to being activated by triggers that, from the outside, seem disproportionate to the reactions they produce. Here is the central point that connects everything explored in this video. The time that passes on the clock is not the time the nervous system records. For the nervous system, a memory is not in the past because it happened a long time ago. It is in the past when the cycle it opened has been fully completed, when the body has received the signal that it can release the charge it has been holding in reserve, when the memory has been integrated with enough context to be archived as belonging to another moment rather than the present. This is why trying not to think about it rarely works the way people expect. Why it's over, I need to move on, may be true on the calendar, but is not the kind of signal the nervous system recognizes as resolution, and why time alone, without processing, is a necessary ingredient, but an insufficient one. If any part of this video describes something you have felt, that sense that an old situation still appears with a presence it should no longer have, leave a comment below. One word. What stayed with you? What changed after understanding the mechanism behind what you were feeling? Because naming what is happening is in itself the beginning of a different kind of processing. Emotional tagging, documented by Larry Cahill and James McGaugh at the University of California, Irvine, shows that emotionally significant situations are encoded with priority by the amygdala, which instructs the hippocampus to consolidate that memory with maximum detail using the adrenaline and norepinephrine released in the hours following the event to make it more vivid and more persistent than memories of neutral events. Bruce McEwen's research at Rockefeller University demonstrated that chronic stress compromises the hippocampus's ability to contextualize memories in time, causing emotionally charged memories to be stored without a clear stamp indicating that they belong to the past and therefore allowing them to arrive with the feeling of being present. The role of sleep in emotional consolidation, mapped by Matthew Walker, Robert Stickgold, and Rosalind Cartwright, shows that REM sleep is the period during which the brain separates, cycle by cycle, the emotional charge from the factual content of a memory. And the memories that most need this processing are often the very ones that sabotage sleep, creating a self-perpetuating cycle. Reconsolidation, demonstrated by Karim Nader, reveals that every time a memory is accessed, it becomes temporarily malleable and can be rewritten by the emotional state present at the moment of access. Anxiously revisiting a difficult memory can paradoxically make it more emotionally loaded than it originally was. State-dependent memory, described by Gordon Bauer at Stanford University, shows that memories encoded in a particular emotional state are more easily activated when the current state resembles the original one, explaining why the most difficult memories tend to surface on days when the system is already overloaded. The default mode network, discovered by Marcus Rachel at Washington University, is the system the brain systematically activates in silence, and it uses that space, together with the capacity for mental time travel described by Endel Tulving, to revisit emotional files that have not yet been fully processed. The shower, the commute, and the silence before sleep do not summon these memories by accident. They remove what was preventing the system from reaching them. Susan Nolan-Huxama's research on rumination establishes the crucial distinction between repeatedly returning to a difficult memory, without new context, without integration, without movement, and genuinely processing that memory. Rumination does not create resolution, it prolongs the emotional state associated with the memory one is trying to overcome. Bessel van der Kolk's work shows that the nervous system does not organize experiences according to chronological time, but according to the degree of complete emotional processing. A memory is not in the past because it happened a long time ago. It is in the past when it has been fully processed. The somatic markers proposed by Antonio Damasio and the concept of incomplete mobilization cycles developed by Peter Levine show that emotional memories do not exist only in the brain, they exist in the body. The physiological response associated with a memory can be activated in a way that is indistinguishable from the response to the original event, making it impossible for the threat evaluation system to automatically distinguish between reliving and living. Now there is a question that, after everything explored here, has probably emerged more strongly than any other. If the problem is not rational, If it is encoded in the chemistry of consolidation, in somatic markers, in the incomplete cycles carried by the body, then what exactly works? And almost everyone, when they arrive at this question, does the same thing. They try to think their way to the answer. They analyze. They reflect. They search for the right argument, the correct perspective, the frame that will finally convince the system that everything is okay. But here's the problem. An activated nervous system does not respond to arguments. Not because it is irrational, but because the threat signal does not travel through the prefrontal cortex. It arrives first, faster, through a pathway that conscious thought, structurally, does not have direct access to interrupt. Trying to convince an activated nervous system through reasoning is like trying to extinguish a fire by shouting at the flames that they should not be burning. The flames are not disobeying, they simply do not respond to that kind of signal. That is the subject of the next video. Why you cannot think your way out of a state that you did not enter through thought. Why the more intelligent, analytical, and determined you are, the more exhausting the attempt to control what does not respond to control can become. And perhaps more importantly, what the nervous system can actually hear when words never reach the right place.